ॐ भूर्भुवस्वः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात्.
I am Salman03. Today in this session I would like to throw light on operating system fundamentals, and the expected audience might be final year students or the freshers, engineering graduates. Right? So operating systems, I would like to first define what do you mean by an operating system. It is very difficult to define what is operating system because operating system has been evolved as the time rolls on. So it would be easy to define an operating system rather than what operating system is. Okay. Meaning it would be easy to define an operating system on what operating system is rather than what it is, because most of the users will see the functionality of an operating system according to their own perspective. The definition for an operating system for the operating system designer will be different from the person who is generally a user of an operating system. So we'll see the operating system definition from the perspective of what operating system does rather than what operating system is. Then it would be difficult for us in initial stages in understanding what is operating system. The first point to be remembered is we know that operating system is a very complex ever written program which is a set of programs. We call it as a software, and we know that according to the engineering principles, software has been classified into different categories. But from this perspective, operating system has been classified into two categories. One is system software and another is application software. And application software. Now, what do you mean by system software and what do you mean by an application software? System software is a software which generally focuses on the operation of computer. If you want to manage the resources of a computer, then we need a few set of programs. If you want to utilize the resources of a computer, then we need set of programs. So those set of programs whose focus is mainly on the operation of computer system or on operation of machine, then we call them as system software. So the main focus will be on operation of machine. It's called a system software. Now what do you mean by an application software? An application software is a software whose focus will be on user convenience, okay, rather than other secondary goals like operation of machine or performance, etc. So the main focus of this application software will be on user convenience. In fact, there are many system softwares, okay, which focuses on the operation of computer, which focuses on the development of computer. So depending upon those, again this system software has been divided into two categories. One is system management software, and system development software. So system software focus on operation of machine, and application software focus on user convenience. System software, the software which deals with the management of resources. Okay, if a system has n number of resources, how to utilize them efficiently, effectively. Okay, those kind of set of programs we call as system management software. Generally, operating system falls in this category, called system management software, operating systems. And system development software are the software set of programs, okay, which are generally used for enhancing the functionality of a system. So the kind of software which is used here, or the kind of set of programs which are used here, are like compilers, linkers, loaders, etc. And the application software are, we know that these are word processors, spreadsheets, web browsers. These are all application softwares. So operating system is a system management, is a system software which manages the resources of a computer. So in layman terms, we will, if I were asked to define what is an operating system, then I would like to define like this. An operating system is an interface between user and machine. So depending upon the different functionalities for managing the resources of a system, we'll give 3 or 4 definitions of operating system, and we'll elaborate them what it is. So operating system is nothing but it's a system software which acts as an interface between user and machine. Now, what do you mean by acting as an interface between user and machine? Suppose here you have a user, okay, and who are really interested in talking to machine, and we know that machine understands signals, it understands binary language. So this user cannot communicate it directly. Why? Because user understands human understandable signals, and this machine understands machine signals. So we need an interface which converts human readable format into machine readable format, and when it has been converted into machine readable format, then machine can process it and gives the response back to the interface, and this interface receives the signals from machine and again converts back into human readable format. So this interface which does this conversion, who is converting user signals into machine signals and machine signals back to user signals, we call this interface as an operating system. So now what is the use of this operating system, or is it possible for us to utilize the system resources without the involvement of this operating system? Yes, it is possible to access all the resources of machine without this operating system, but this user has to do lot of low level activities, and this user has to directly interact with the machine, which is very cumbersome and irritating. So that's why people want convenience. That's why the operating system has been introduced. So there are many goals for developing an operating system. Okay, the primary goal we cannot say actually. It depends upon what type of system you want for. For example, for operating system designers, might be the goal is performance, and for general users, the goal of operating system will be user convenience. But the larger community which uses these operating systems are generally users. That's why we will take primary goal of your operating system is convenience, and secondary goals can be performance, efficiency, so on. So operating system here is acting as an interface between user and machine. This is one of the definitions of an operating system. Now user in fact directly cannot interact with the operating system. There is still one more interface between user and operating system. Okay. This interface, the user will be interacting with this interface in order to interact with the operating system, which in turn interacts with the machine. Now we call these interpreters are generally command interpreters. We call these interfaces as command interpreters. let's say let's take an example of an operating system called DOS, disk operating system. Now this is a very small operating system, and if the user want to interact with this operating system, it cannot talk directly to this. It uses one more interface called command prompt. Okay. The command interpreter for DOS is command prompt. Now rather, if the operating system is not DOS but it is Windows, which is GUI based, graphical user interface, then the command interpreter here is desktop. So whenever we are interacting with the operating system, we are actually not directly interacting with the operating system, we are using these command interpreters. So desktop is a command interpreter for us to interact with the GUI based operating systems. Now nowadays in Linux flavor we have good GUI operating systems, but generally the command interpreter for those which are Linux flavor operating system we call them as shell. So user is not directly talking to the machine, okay, he is talking with the help of operating system, and in fact he is not directly talking to the operating system, he is interacting with the command interpreters, and these command interpreters will vary from operating system to operating system. So this is the meaning of operating system is acting as an interface between user and machine. Now let us see the other definitions of operating system. Operating system acts as a resource manager. And operating system, it is a software which controls the flow of execution. It is a software which controls the flow of execution. Now let us see what do you mean by operating system acts as a resource manager. So here let's take an example of any organization where many employees are working, and that organization has many resources, and how the manager will use those resources. In the same way, operating system will also use all these resources. So it is acting as a resource manager. For example, I have a disk. Okay, how this disk has to be utilized efficiently and effectively. If I have a CPU, CPU is also one of the resources. Then how these resources will be utilized efficiently and effectively. When you talk about here resource, what are the different resources which are there? These resources can be hardware resources, or it can be a software resources. From one window, if you see, these are the resources. If you see from another window, the resources can be consumable resources or reusable resources. Or reusable resources. Okay, what are the examples of hardware resources? Hardware resources are nothing but your memory, hard disk, printer, all the devices which you can physically which you can touch them. And software resources are nothing but processes, signals, etc. All these are the software resources. What are the consumable resources? Consumable resources are those resources, okay, which when they are generated and can be used only once. Okay, for second time they are not available. Reusable resources are those resources when once you have this kind of resource, you can use it at, you can use this resource any number of times. Okay, take an example of memory. Memory is a reusable resources. If you have one process loaded into the memory, okay, that memory part can be reused for n number of other processes at different point of times. Right? So those kind of resources are called reusable resources. Consumable resources, I think the good example would be signals. Okay, signals, when once they are generated, okay, they are consumable. Okay, if you handle that signal, it's okay. Otherwise, it simply gets ignored, and you cannot regenerate the same signal. Other signal of same type can be regenerated, but that signal was consumed. Okay. So the duty of operating system is to manage all of these resources efficiently and effectively. Okay. So it is something like your operating system is acting like a government, like how government provides facilities for its citizens without involving into the work of themselves. Okay, it creates a good environment in which they can do work properly. Okay, in the same way, your operating system provides a very good environment for the programs to execute. It provides a very good environment for the programs in order to execute themselves. It means whenever you write any program, it is not necessarily for you to deal with all low level details to talk to machine. Okay, you need to know only the higher level calls, and the operating system will take care of all the lower level details. Okay. So in fact, you can write this as well. Operating system is a set of utilities which eases the application development. So if I want to go from here to my home, okay, I need not lay road myself and go there because it is the government which is providing me this facility, and we are using this. Similarly, for writing any program, I need not bother about how to load this program into memory. Okay, then in which area of this memory this process has to set, and how to control its flow of execution. All these lower level details we need not bother. It is the operating system duty, it is the operating system responsibility which takes care of all these lower level details, right? So that's what the operating system is, also a set of utilities which eases the application development. It doesn't involves in your application, but it provides a platform for you to develop an application so that you can develop applications easily and effectively without involving yourself into the lower details of machine. Yeah. Then we have it is a software which controls the flow of execution. Now let us understand this, which is very important. Actually, these are not the definitions of computer. It's not a definition of operating system. These are actually the definitions which I have given according to the functionality of an operating system. As I have told you in the beginning, defining an operating system is very difficult, right? So it would be easy to define an operating system depending upon what its functionality rather than what this operating system is. So these are actually different perceptions from different windows. We are viewing this operating system and we realize that yes, operating system is acting as a resource manager. Now I have given a statement that operating system acts as a resource manager, and it is a software which controls the flow of execution. It is a set of utilities which eases the application development. It is acting as a interface between user and machine. So these are actually different functionalities or phases of your operating system. Now let us understand what do you mean by operating system controls the flow of execution. We know that according to the von Neumann architecture, which is based on stored program concept, and also it depends on sequentially a flow of execution. It means whenever a program has been written, the program will be executed in the same order in which the instructions are appearing. So how it is possible to execute all the set of instructions sequentially? Now this the operating system actually which is making it possible to execute all the set of instructions in a sequential manner. So now let us see the block diagram of computer. We know that here we have input devices, okay, and we have central processing unit, and we have output device. Okay. Now this CPU, we know that it has been again divided into control unit and arithmetic and logic unit, and we have memory. Okay. What is memory actually? Memory is nothing but it is an array of words, and each word has a specific address. Each word has specific address. And whenever I write any program, for example, I have written a program and I have given this to machine for execution, then this set of instructions has to be loaded into the memory. Okay. So at this memory, all these instructions might be residing, okay, and they have specific addresses. Now let us see how this operating system makes it possible that the sequential flow of execution is done by the operating system. Okay, how this operating system will execute this set of instructions sequentially. So let's elaborate on memory. Memory is of actually 2 or 3 types. Okay, it can be a primary memory. Here memory means what, okay, and what it is not. In order to understand that, let me classify this memory. Memory can be classified into primary memory, or it can be classified as secondary memory. Or territory memory, right? Like tapes and all. Primary memories, examples of primary memories are RAM, or it can be random access memory, read-only memory, and secondary memory are nothing but hard disks. Okay. Territory memories can be tape. Okay. So when I am talking about this primary memory here is RAM. Okay, it's RAM. So what is RAM? RAM is a temporary memory which it's actually a random access memory. Access to this memory randomly is possible, and it holds data temporarily. When the system shuts, then all the contents of this memory will be erased. And there is another kind of primary memory which is called read-only memory. Okay, this read-only memory is the memory generally where bootstrap is sitting. Okay, what is bootstrap? Bootstrap is a the name itself gives you the meaning. Bootstrap. Strap is nothing but a small program. Strap is nothing but a small program for starting the machine. Boot is nothing but starting up or bringing up your system. So booting is nothing but here bootstrap is a small program, okay, which is actually a small operating system. When you switch on the machine, this bootstrap will be loaded into the main memory from ROM to RAM, and this bootstrap is responsible for bringing the operating system. When the system is off, the operating system was sitting in storage, secondary memory, hard disk. Then how do you bring this operating system into main memory, into RAM? This is possible with the help of this bootstrap program. This is a small program which helps us, okay, in bringing the part of the core part of kernel from hard disk to main memory. Okay. Now there are few systems that doesn't has disk. Those are called diskless systems or diskless host. Now how this diskless host will be booted? Generally this diskless host they have RAM, they have memory, but they don't have secondary storage. Now if I want to boot them, they cannot be booted locally, as in our case generally our local computer or personal computer, it has memory and also secondary memory. When we when we start the computer, the bootstrap will be loaded from ROM to RAM, and that bootstrap is responsible for bringing the memory bringing the operating system back into the main memory, and from then onwards, system starts. But for those systems that doesn't has hard disk, it means it doesn't has any operating system. Operating system is sitting somewhere remotely onto the remote machine. So in the earlier case, it is called local booting, and in this case where a system doesn't has any disk and it want to boot, it has to boot with the help of communication links. Okay, so this is called remote booting. So a system, it is possible to have a system which are diskless. Then how to boot them? We'll boot it with the help of communication link, and this kind of booting is called remote booting. So we have two types of booting. One is local booting, generally which we'll do on our machines, and another is remote booting, and it is used for only those machines that doesn't has any secondary storage. There are other parts of memory which are actually sit inside this CPU. We call them as latch memories, cache memory, L1 and L2 memories, registers and cache memory that sits inside this CPU, on top of CPU. So now this is what all about memory. Now this memory, when I am talking about this RAM, okay, read-only memory. Now this RAM has a memory set of sequence of words. Each and every word has specific address, and these instructions are loaded into this memory. And I have registers, okay, like program counter and instruction register. These are the two registers which help us in executing the program sequentially. Now see, what happens is program counter always points to the next instruction to be executed. Suppose the next instruction to be executed is I1. Okay. Now it will have the address of program counter will have the address of next instruction to be executed, and instruction register will have the instruction itself, which actually it want to execute. So I1. This is I1. Instruction register has instruction itself. So when program counter is pointing to the next instruction to be executed, okay, depending upon to which it is pointing, instruction register goes to that location and bring it into the instruction register. Actually these operations, controlling these signals, okay, is done by your control unit. Control unit is actually responsible for all signals and executing micro operations. Micro operations at this point of time, remember, micro operations are the operations which are very atomic. Okay, it means a higher level instruction like C is equal to A plus B can be represented into many number of micro operations, okay, which is very close to machine. So control unit is responsible for execution of those micro operations and giving signals and cooperating among all these functionalities. Now, when program counter points to the next instruction register and instruction registers hold this instruction. Okay. Now there are few cycles which are used to which are needed for executing an instruction. How actually an instruction cycle is executed? How an instruction is executed? So an instruction is executed by a series of instruction cycles, by a series of few cycles. What are those cycles? We'll see now. So the very first thing is fetching an instruction. It means the instruction has to be fetched. Now I'll assume this as equation 1 and this is an equation 2. Then combination of this equation 1 and 2 is called fetching of instruction. Okay, it's nothing but fetching of an instruction. Now once the instruction has been fetched, okay, now this instruction I have to decode this, whether this is an instruction or it is a data or it's an instruction, we don't know because it's in memory. So once instruction is fetched, it is called fetch cycle. So I'll write it here. instruction fetch cycle. Then next I have instruction decoding cycle. What do you mean by instruction decoding? The instruction, whenever it is sitting inside memory, I don't know whether it's an instruction or it's a data, right? In decoding cycle, we'll come to know about whether it's an instruction or data. Now, suppose it's an instruction, then that instruction, like it might be an instruction like C is equal to A plus B. Now, I know that it's an instruction, and I have decoded the plus operation. The operation has to be performed is plus, but I have operands. Okay. Now, this operands also has to be fetched. Is it or not? So, this is called operation fetch. Operator fetch cycle, or fetching an operator. Operator fetching cycle, and third is called finally fourth is execution cycle. So an instruction is generally executed by the series of these 4 cycles. First, the instruction has to be fetched, then it has to be decoded, then operator has to be fetched, then execution has to be performed. So these are the 4 cycles which are needed for an instruction to be executed. So all this will be controlled by the operating system. So operating system does this with the help of these registers and executes and controls the flow of execution. Right? There is one more cycle called interrupt cycle, which I have not mentioned here. What is this interrupt cycle? Generally, interrupt is nothing but interrupt cycle. Whenever any signal is sent or whenever any process needs attention of CPU while an instruction is executing, okay, then it can do so with the help of this interrupt, right? So whenever an interrupt is raised, interrupt is nothing but it's a signal. Okay? When this signal is sent, then for each and every signal in operating system maintains a table. Okay, that table contains, it is called as interrupt service routine table. Okay, it contains code for handling those signals, right? So whenever any interrupt comes in between doing this instruction fetch or in between instruction decoding, then this interrupt will not be entertained. Okay, whenever any interrupt comes, okay, so it will first complete the current cycle and then it will service the interrupts. Okay, so interrupts will be serviced with the help of interrupt service routines. So this is the meaning of operating system controls the flow of execution. So it is the operating system which is controlling the flow of execution. Whenever you write any program, how the sequence of execution is happening, it is this the operating system which is doing this, okay, with the help of all these instruction cycles. Okay, as I have told you that operating system has evolved from it has been evolving as the time rolls on. So depending upon that, the functionality of an operating system has been changing, and depending upon that, we are going definitions. We are giving definitions of an operating system. So initially, when the operating system was when there was no operating system, okay, we'll just talk about the evolution of operating system. In order to understand the functionality of an operating system, it is important to know its evolution, because once we know this evolution, then we will come to know that depending upon what problems what functionalities has been accommodated, and how this operating system has grown, and what are the different functionalities at what time, at what point of time they have been included. We'll come to know that, right? So when first the first type of system that has been created called serial processing system. Serial processing system, or we also call it as sequential processing systems. Now, what do you mean by this serial processing system or sequential processing system? See, these are actually the days of punch cards. So, generally they are used by only the skilled programmers. Whenever we want to write any program, first that program has to be written on card reader, has to be written on punch card. Okay, then it has to be read with the in card reader. Then it has to be taken into another room for printing the output. So it means at that time executing a program was very difficult, and here we don't have any concept of operating system. We don't have operating system here, no operating system, and generally it was used by skilled programmers. The problem was for typing onto the card and reading this card. For typing something onto the card, we go to room 1, and for reading that card reader, we go to another room, and for taking printout, okay, we go to third room. There are different rooms, okay, which has been dedicated for different activities. So the person who want to complete his job or who want to execute this job, he has to move between these rooms. And you imagine what happens in case of any error. Okay, again, he has to repeat all the tasks again. So that's what, there was lot of manual intervention. Manual human intervention was involved. And because of this, we know that machines are very fast than human beings. So most of the time, really it takes much time for a person to take one job from one room to another room. We actually do in minutes, and computer solve the problems in milliseconds and microseconds. So that's why most of the time your CPU used to be idle. CPU was idle most of the times. So now, and our goal is how to use this CPU idle time so that the utilization of CPU should be very high. You can use the utilization can range from 0 to 100%. So we want to achieve some good number in CPU utilization, and inefficient utilization of resources was also one of the reasons in serial processing. Inefficient resource utilization. Now, because of this problem, because of this, serial processing, lot of human intervention is needed. Another system comes which is called batch processing. Now, in batch processing, we have few things here. Batch processing. In batch processing, we'll take same set of jobs. Okay, jobs are nothing but processes, or same set of jobs, and make a queue of these jobs. And here jobs are running: job 1, job 2, job 3, job 4, job 5, and all these jobs were taken together and submitted to the machine. When we submit to this machine, then machine takes job 1 and complete this, and it takes job 2 and complete this, and takes job 3, completes it. But if suppose job 3 has some error, then this process halts here. It halts here. Now here there is still human intervention is required here. Why human intervention is required? Because here when we are submitting jobs, all these jobs should be of same type. Like if I might be giving all C programs or all COBOL programs to machines, and moreover, whenever you are giving any job to this batch processing, that job should not be interactive. It means that doesn't requires human intervention in between, meaning accepting some input. Okay, that kind of stuff should not be there in those jobs. Only those jobs can be submitted in batch processing. It means that when a job is submitted and that job in batch processing has no ability to interact with the user, there is no interactivity, and same set of jobs are used. Now suppose I have two sets of jobs, one is C and another is, for example, this COBOL. Two sets of jobs. Now I can submit this. Okay. Now this set of job, after completion of this set of job, now again I have to load this another set of job. Again still, even though the CPU idle was not that much when relatively, but CPU has been utilized, but still it is considered as idle because most of the time has been inefficiently utilized, and also inefficient utilization of resources persist. But here what we did is we could able to run multiple programs sequentially, one after the other. Okay. Then there was a small refinement in this batch processing. What the people did is they have developed the first operating system here. Okay. Now this first operating system, we call it as a monitor or resident monitor. Okay. The name itself tells resident monitor. It is residing in the memory all the times, right? So the main job of this resident monitor is to keep track of which job is ending and at what time of what is the starting address of another job. Okay. Now this makes all these things possible. But again there is a problem. What is the problem? The problem is because of this monitor we could able to run multiple jobs, but we don't know the other kind of job, like other set of jobs, okay, where from where they are starting. Okay. Now this information we can give to this monitor. Now how to give this information to this monitor? In order to give this information to this monitor, we use a language called job control language, JCL. This is job control language. Then after this batch processing system, then comes multi-programming systems. See, the drawback in batch processing is I can load only one set of job. It means the memory was inefficiently utilized here because I don't have concept of loading multiple processes simultaneously into memory. Now multi-programming is the concept or it is an ability of an operating system to divide this memory into multiple parts, into multiple partitions, so that simultaneously I can accommodate multiple processes into memory. It doesn't necessarily means executing multiple processes simultaneously. It is the ability of an operating system to accommodate multiple processes simultaneously into memory. This is possible by dividing this memory into different partitions, and we load job 1, job 2, job 3 and job 4 into this memory. Yes, we were talking about this multi-programming. Multi-programming is the ability of an operating system to accommodate more than one processes into memory. Now, what is the problems with batch processing? The following are the problems with batch processing. In batch processing, yes, it is good that you can give multiple jobs, but all those jobs are of same type. Okay, they are of same type, and all these jobs will be processed by the CPU in a sequential manner. Okay, that's why it's called job sequencing. It is also called as job sequencing. So all the jobs are executed sequentially. And third problem with this batch processing is, when a job is executed or when a job is executing, it cannot interact with the user. Okay. Job cannot interact with the user while executing. Now, how to overcome this problem? This problem has been overcome with the help of this multi-programming. Now here, multi-programming, as I have told you, it is the ability of an operating system to load multiple processes or multiple jobs of any type, right? And all the jobs need not be executed sequentially. Now it is the responsibility of the scheduler which takes or which selects randomly any one of these jobs depending upon the scheduling algorithm. Now there are many scheduling algorithms which we'll see in our next session, that first come first serve, and shortest job first, shortest remaining time first, highest response ratio next, and round robin. There are priority based scheduling. These are the different types of scheduling algorithms, right? So here in multi-programming, it is not necessary that the order in which the jobs have been loaded, in the same order these jobs have to be executed. There is no such restriction. It is up to the scheduler to pick up any one of these ready to run job and start executing them. Now, however, multi-programming doesn't solve this third disadvantage, which is actually overcome in time sharing system, which is our next topic of discussion. So let's complete this multi-programming. Now there is one problem. There is one advantage of multi-programming over non-multi-programming systems. Okay, here I will have multi-programming, and here I'll have non-multi-programming systems. So in non-multi-programming system, what happens, you can have in memory an operating system, either it can be at lower or upper part of the memory, and you have ability to load only one process into the memory. Suppose the size of this memory is 64 kilobyte and the size of this process is only 15 kilobytes. Okay, then how much memory we are wasting? We are wasting 64 minus 15. Okay, that kilobytes of memory has been wasted here. But whereas in multi-programming, the same memory can be divided into multiple partitions, and depending upon the size of partition, the operating system will load this process and accommodate that process into appropriate partition, okay, in order to efficiently utilize these resources. Now here, however, we overcome this manual intervention. There is no manual intervention, and we are to bit level successful in utilizing the CPU idle time. Okay, CPU was relatively utilized well, and memory we are utilizing memory very efficiently, because we have we have divided logically this memory into many partitions, and we are welcoming all the other processes depending upon their size and the partition size, and it is this the operating system doing, and this is called multi-programming, allowing more than one process to reside in memory. Okay, now while in this multi-programming, okay, and what is the main difference between systems which are non-multi-programming and the systems which are multi-programming is this. Now assume that this process P1 has been given to CPU. Now I am talking about non-multi-programming system. So when process is executing on this CPU, I have this CPU, and process P1 is executing on CPU. I am talking about this non-multi-programming. Now assume that there is one instruction which is executed by P1 for an IO operation. So now what happens? This process will go and perform some IO operation. That IO operation will be carried out by some IO device, and till that amount of time the process goes and completes its execution and again come back and schedule onto this CPU. All this time duration, the time where the process has left and came back to CPU, a considerably good amount of time, that all the time CPU was idle. CPU was idle all of that time. But whereas in multi-programming, what happens is, suppose a process has been selected randomly among number of jobs available and has been given to CPU. And suppose this process want to execute some IO operation. What happens? This process will go and perform IO operation, and the scheduler and the operating system will select any one of those jobs which are present in the partitions. Okay, will select one of them and give it to the CPU. It means those idle time which was there in non-multi-programming, we are successfully in utilizing it, and also the memory which is there in non-multi-programming, we are utilizing that as well. So we are efficiently and effectively utilizing both CPU and also memory. So the idle time is relatively lesser than in non-multi-programming. So we are successful in doing bit level more, making your CPU busy in this multi-programming. Then again we have few drawbacks for multi-programming, like what are the different things. Before I go to this time sharing system, which I will do in next lecture, I would like to conclude this by one more important point in multi-programming. In multi-programming, when this process leaves CPU, okay, suppose this is your CPU and this process P1 has been given. So this process P1 leaves CPU only under two situations. One situation, either this process has completely executed it and terminated, it has been finished and it has no more instruction to execute. In that situation, the process P1 leaves the CPU, or this process P1 will also leave the CPU if it is performing some IO operation. Okay, but whereas in non-multi-programming, a process leaves CPU only if it has terminated, then another process has to be loaded from the disk into the main memory, and again it will be given to CPU. When that process is performing any IO operation, CPU was idle. But here, when process has been given to CPU, when it has completed its execution, it's okay. If it is performing some IO operation, here still the scheduler is taking some other job and giving it to the CPU. So in multi-programming, CPU can be the process leaves the CPU either when it has finished its execution, or it is performing some IO operation. Okay, that is actually happening. That actually happens in multi-programming with non-preemption. Okay, so in next lecture we'll talk about multi-programming with preemption and what is time sharing, and then we'll do few problems on scheduling algorithms.